Okay, so so the thing that I'm going to be learning in this chapter is about automatic repeat request (ARQ), right? So I'm going to be reading Geeks for Geeks article on ARQ first before I try to understand what exactly I'm going to be learning about it. So before going into the reference books, that I'm going to be reading this overall article provided by Geeks for Geeks. So let me start with this. What is ARQ? Automatic repeat request. So ARQ stands for automatic repeat request, also known as automatic repeat query, or query is query, right? So ARQ, automatic repeat request, or automatic repeat query, is an error control strategy used in two-way communication system. It's not used in one-way communication system like broadcasting or somewhere else. No, we don't use it there because ARQ means the receiver sends an acknowledgement to the transmitter who sent the initial the original message. So when it receives a message, it has to send an acknowledgement packet or a frame to the original sender in order to make sure that it has received the message. But in broadcast and one-way communication systems, we don't have such feature because we don't communicate. We don't get any message from the receiver. So that's how it works. So it's a group of error control protocols. So we have multiple protocols defined in this. Yeah, that's cool. Protocols to achieve a reliable data transmission over an unreliable source or service. So as per them, what these appears to be used in unreliable source or services. Like when we are certain that the data being sent by the transmitter will certainly be received by the receiver. We don't need such error control protocol, right? We don't need to get acknowledgement from the receiver for each and every packet we send. So this is certainly be used in unreliable communication medias. Like also, this is let's go further. These protocols are in transport layer and data link layer of the open system interconnection model. So the OSI model, these protocols are residing in data link layer and transport layer. So we will look into the later. These protocols are responsible for automatic transmission of packets that are found to be corrupted or lost during the transmission process. So from my early understanding of this ARQ protocol, this is how it works. Like, for example, the transmitter is there and the receiver is there. Transmitter sends a packet to the receiver, and the receiver has to acknowledge the packet that is received from this transmitter. Then only it starts. So it depends on which protocol under the ARQ we are going to be using, but this is the basic principle in this ARQ. So with that, I'm going to be going ahead. So they're saying that these protocols are responsible for automatic transmission packets, so automatic retransmission of packets, okay? When there's a packet lost or corrupted, the receiver asks to send. It's not that it asks to send a packet. Then it's not automatic repeat request, right? So it is decided by the transmitter itself before it resends the packet. So Let's go further to understand further, right? Working principle of ARQ, the main function of this protocol is the sender receives an acknowledgement from the receiver and implying that the frame or packet is received correctly before a timeout occurs. So there has to be a timeout because the sender that is sending the data has to wait for a certain period of time before it sends the data again, right? That's what we call a timeout period. We define a time. It waits for a period of time before it decides to retransmit or not, right? So that's what we call a timeout. That's certainly fine. Timeout is a specific time period within which the acknowledgement has to be sent by the receiver to the sender. So that's a cool thing to know. Then if a timeout occurs means we have passed the time we defined, but we haven't received any acknowledgement packet so far. Then the sender that does not receive the acknowledgement before the specific time, that's fine. It's implied that we can't be certain that that packet is lost or corrupted, but we can we just imply that the frame or packet has been corrupt or lost during the transmission. Accordingly, the sender retransmits packet, and these protocols ensure that this process is repeated until the correct packet is transmitted. It doesn't care about how many times it has to retransmit, but it transmits packets again and again and again until it gets the acknowledgement. So let's go further. And there's a communication model in the image. I'm sorry that I cannot display this screen. I don't have a streaming software set up on my MacBook so far. I will try that later. So applications. So what are the applications of this ARQ is ARQ probably have a wide range of applications as they provide reliable, probably I'll have to memorize these things if I have to, otherwise, because I can't remember them, because these kind of new things for me. New things in the sense, these are like kind of complex stuff, right? These protocols are mainly functional on shortwave radio to ensure reliable delivery of signals. For the same function of ARQ, there are various applications: transmission control protocols, specific service orientation protocol, high-level data link protocol, IBM binary synchronous communication protocol. Okay, fine, it's model. So there are kind of things that, yeah, I really don't care. I'll try to memorize them before the exam. Fine. So we are going to talk about the main thing of ARQ types. What are the types of ARQ we have? So let's go ahead. There are several types of ways in which these protocols function in the data link layer. So in data link layer, we have several types how this protocol works. Right? This automatic repeat query or automatic repeat request protocol is going to work in different ways. The first one is stop and wait ARQ. So I have already read this section, so I'm going to be talking this. Okay. So stop and wait ARQ works like this is more of a redundant and more robust. Okay, so when there is a transmitter and receiver, it sends one packet or one frame. Remember that. Okay, one single packet or one single frame. It sends one, and the receiver has to send an acknowledgement packet before the timeout occurs. The sender does not send any more data, any more frames, any more packets until it receives an acknowledgement message within the timeout period. Okay? Only after it receives the acknowledgement, it decides that the receiver has received the packet successfully, then only it sends the next consequent packet. That's 1.2. That's what we call stop and wait. So we send it, stop, and wait until the acknowledgement occurs or the timeout occurs to retransmit. So stop and wait ARQ is also referred to as the alternating protocol. It's a method used in two-way communication system to send information between two connected devices, sender and the receiver. It is referred to as stop and wait ARQ because the function of this protocol is to send one frame at a time. They are bolted that. After sending a frame or packet, the sender doesn't send any further packets until it receives an acknowledgement from the receiver. We already know that. Moreover, the sender keeps a copy of the sent packet. So you have to know that point. I mean, I have to know that point because I'm the one going to write the exam. Okay. So when it sends the packet, it doesn't delete the packet because it doesn't know whether the receiver has received it or not. So it keeps a copy of the packet that has sent already. So it keeps the packet, wait for the acknowledgement message. If the acknowledgement is ready, is received, and then yeah, it gets rid of the packet and it prepares and send the next packet it is supposed to send. What if the timeout occurs? Yeah, it has to send the packet again, right? So it needs to keep the copy of the packet that is being sent in one transmission. Okay, the okay. Then let's go to the go back and ARQ protocol. So go back and ARQ means go back and ARQ. So there is an N, that means a number is there. A number is employed here, right? So this number, we define it. So let's go through this article and try to understand what's happening. So go back and ARQ is a type of the ARQ protocol in which the sending process continues to send several frames of packets even without receiving an acknowledgement packet from the receiver. So in stop and wait ARQ, what we did was we sent one single packet or frame and wait until an acknowledgement comes. One single packet. But here, we don't stick with one. Rather, we go beyond one. Like we send a couple of packets, 3 packets, 4 packets, 5 packets, and we define it right. We just don't send it randomly. I mean, this protocol defines a value for n. We define how many packets we can send before receiving an acknowledgement for a single packet on the transmission. Let's say n is 5, then we send 5 packets to the receiver, right? Without bothering about whether we are receiving an acknowledgement for each packet we are sending. About that, acknowledgement for each packet means, in packet switching, we don't worry about, let's say we have like, for the entire message, we have like 10 packets cover the entire message. We don't worry about which order the packets are going because we don't know which path in the network the packets are going to take based on the routing algorithms, right? So what we do is we slice the entire messages into the packets and we add a sequence number to the packet headers, right? At the receiving point, after all the packets are received, we have to see there is a sequence number in each packet. Then only the receiver can accomplish the task of receiving the entire message, right? Otherwise, the data is lost. So the receiver, when it receives messages, when it receives packet in this protocol, go back and ARQ protocol, let's say if n is 5, then when it receives a packet, it has to check if there's a sequence number in it. If there is a sequence number in it, then it has to add that number to the acknowledgement message and send it. Then only the receiver knows, the transmitter knows the receiver has received this packet, right? Because in stop and wait ARQ, what we did was we are sending one single packet at a time, right? So when an acknowledgement comes, we certainly know that that acknowledgement for the packet we sent is not from the previous or the future messages, right? It's exactly for the message we sent, for the packet we sent. But here we are saying multiple packets, multiple in the sense the defined number of packets before we receiving complete acknowledgement for all the packets, right? So at this point, we need to know that which packet this acknowledgement message is for, right? So that's why the receiver is adding that sequence number to the frame. to the acknowledgement frame. So let's read. The receiver processor keeps track of the sequence number of the packet it expects to receive and sends the sequence number with the every acknowledgement to the sender. The receiver will remove any packet that does not have the desired sequence number it expects and will resend an acknowledgement for the last correct frame. So if the packet the receiver receives doesn't have a sequence number, then it removes the message and asks for retransmission of the data it received. That's clear. There are only, I mean, the, so about this, there are only two possibilities that frame won't match the sequence number. One, it's either a duplicated frame of an existing frame, so we'll already receive the frame, or an out of order frame that needs to be sent later. If you don't, I mean, the receiver needs to receive the packets with the sequence number, right? If you don't have, if you don't receive them in the order, I mean, the receiver expects to receive, then it has to, lose the message and ask for the message to be sent with that sequence number it wants, right? So once the sender has sent all the frames in its window, it will identify that all of the frames since the first lost frame and will go back to the sequence number of the last acknowledgement signal that it received from the receiver PR and continue that process over again. The only drawback of this type of system is that it results in sending packets multiple times. If any frame was lost or found to be corrupted, then that frame and all following frames in the send window will be retransmitted, right? So if it is in the stop and wait, we are sending only one frame. If that frame is lost, we retransmit that single packet only. But in here, I mean, in this go back and out protocol, we send like 5 packets in a sequence. If there is one single packet doesn't have an acknowledgement, what we do is we have to send all those 5 packets again. That's one type of drawback in this. Okay. Then selective repeat arc, selective reject arc. So that's one type of thing we need to, you know. So there is one question in my tutorial provided my professor. It's like with a k-bit sequence number field, the maximum window should be 2 to the power k. Why the maximum allowable windows is set as 2 to the power k minus 1 in go back and arc. I'm going to Google that question to see what's happening. I'm going to Google as maximum allowable window side window in go back arc protocol. I'm pretty sure Google will be like, let me just go ahead and see. There's an article talking about window size for go back and arc. So m is equal to q, which means the size of the window can be 2 to the power m minus 1 or 3. We can now show why the size of this window must be less than 2 to the power m. If the size of the window is 3 and all 3 acknowledgements are lost, the frame 0 timer expires and all 3 frames are reset. The receiver is now expecting frame 3, not frame 0. So the duplicate frame is correctly discarded. On the other hand, if the size of the window is 4 and all acknowledgements are lost, the sender will send a duplicate of frame 0. I mean, I'm confused. Okay, let me reread this thing, okay? We choose m is equal, okay, m is fine. And the value should be less than 2 to the power m. So they are designing on 2 to the power m minus 1. That appears to be the case here. They are choosing m is equal to, for example, to the m minus 1 means to the power 2, 4 minus 1 is 3. Okay, we have 3. The window size is 3, as they chose correctly, 3, less than 2 to the power 2. Uh, when there is 3 acknowledgement needed from the receiver, right? From the receiver. If all 3 are lost, the frame 0 timer expires, right? Frame 0, what is frame 0? I don't know. 0, 1, 2, is it the case? Yeah, I think so, right? For in each window we have window, in the sense that that's what we call the window. In each window we send certain packets, right? Number the n. That's what they are referring to the window. So if the size of the window is 3 and all 3 acknowledgements lost, the frame 0, 0, 1, 2. So they're counting from 0 as it appears to be in this, right? I don't know. 0, 1, 2, 3. Um, Windows 3. The size of Windows 3. Uh, frame 0 timer expires and all 3 frames are reset. The receiver is now expecting frame 3, not frame 0, so the duplicate frame is correctly discarded. On the other hand, if the size of the window is 4 and all acknowledgements are lost, the sender will send a duplicate frame 0. However, I mean, oh, okay. So if the sequence number, k-bit sequence number means, let's say we have, I mean, here they have 2-bit sequence number. Here we have 2-bit sequence number. So why the size of the same window must be less than m. The size less than 3. 2 bits, in the sense we have like 2 to the power 2, right? Ah, we can, like, this is what's going to happen. We have, how many packets do we have? Sequence number. We have 2-bit sequence number means we can have maximum 2 to the power 2, 4 packets, right? 4 packets we can send, right? I don't understand this. I found another article that I'm going to be referring, because it's kind of confusing. It's 25 minutes since I started this stream. Means I started this topic earlier than that. Let's see how it goes. Uh, what is this article? Lund University, land, I don't know, electrical information technology, communication network. Okay. Uh-huh. I think this is a question. It has solutions. Seems like, okay. Good question number 8. In Go backend ARQ, the size of the sender window must be less than 2 to the power m, where m is number of bits. Okay, question number 8. Let's see if the solution has the answer. Okay, it has it. In a communication system, the sequence number is represented by m is equal to 2. So m is equal to 2 means we have 2 bits. We can have 2 to the power of 2. For, I mean, 2 to the power of 2. Four maximum packets in that sequence, right? And is thus able to hold to the 4 frames. We can have 4 frames, 4 packets. The sliding window size also was 4, right? If the n is also 4, and the sender has transmitted all 4 frames, means the entire message is done, right? In the sequence, but the acknowledgement for frame 0 has not been received. I mean, we have 4 frames because our window size is, the sequence is 2-bit, so we can have maximum of 4 frames. So 0, 1, 2, 3 frames, right? 4 frames in total. Let's say we are sending, if the window size is also 4, 2 to the power m, 2 to the power k, right? 2 to the power 2 means 4. If the window size is also 4, we will send all these 4 to the receiver before we check for the acknowledgement, right? We sent all these 4. Let's see if the frame 0, we didn't receive the acknowledgement for that. Okay, let's read further. Nevertheless, all frames were received on the receiver side. Let's say if all the frames are received on the side, if the sender was now to retransmit the first frame, right? If the frame 0, if the sender is not has not received the acknowledgement for the frame 0, but receiver has received all the messages, right? Sender will have to retransmit the first frame, which is the 0th frame, right? 0, 1, 2, 3. Then the receiver would treat that as the first frame in the subsequent sequence. So, we have the transmitter, we have the receiver. It is sending 4 frames, all 4 frames on the message, right? Because the window size is equal to the sequence the sequence number represented by 2. So the maximum frames it can hold, it all sent. But the transmitter did not receive. That is a problem happening with the acknowledgement message, not the message transmission. Only the acknowledgement part is being wrong. So the 0th frame, the transmitter, the sender did not receive an acknowledgement for it. So it will start to send all the 4 packets again. Did you get it? Right? Did you get it? Again. Let's say the receiver has already received the entire packet sequence from the previous transmission, but the acknowledgement message is the only thing that failed to be received by the sender. What will happen? He doesn't know whether the receiver has received the acknowledgement or not, right? The receiver doesn't know that the acknowledgement is sent successfully or not. It only sends the acknowledgement. because now it has complete message from the previous sequence. When this retransmits the same message, the receiver will think that that is coming for the next message sequence. Did you get the point? So, if the acknowledgement is lost by the sender, the receiver doesn't know that. The receiver will keep track of all the previous four messages it has received. It will keep that as one message sequence. That's fine because that's a successful transmission. This does know that. So it is retransmitting the previous message, but this receiver think that that is the first frame of the next sequence. You get the point, right? And it sends a acknowledgement for that. But this will think that that is the acknowledgement for the first sequence message that is currently being retransmitted. But what's happening is the acknowledgement received is for the second set of sequence, right? This is something not tolerable in this communication, right? And because in the first sequence, it only, I mean, the entire. I get the entire point. Very clear, right? So with that, I'm going to stop the stream because I understood very good thing today.